Bismillahirrahmanirrahim. Today we will discuss about the standardization of death rates, and I am presenting under the kind supervision of Professor Dr. Saira afzal. The learning outlines of today's presentation is what is standardization, death standardization with example, index and MCQs. By the end of this presentation, participants will be able to describe the use and interpretation of age-adjusted mortality rates and ratio. Now, first of all, we will discuss and have a brief overview of the crude death rate. Crude death rate equals to the number of deaths during the year by mid-year population multiplied by 1000. Here we can see the crude death rate to Sweden is 9.1 per thousand population, while that of Pakistan is 6.8 per thousand population. What does it mean? Is whether the Sweden's health indicators or health status is much poorer than Pakistan? No, this is not the situation. We can because we can see that the Sweden's older population is much more as compared to Pakistan. So that's why we can say that Sweden's CDR is much more than Pakistan. So what is the limitation of the CDR? It is that if we want to compare the death rates of two populations with different age composition, the crude death rate is not the right yardstick. This is because rates are only comparable if the population upon which they are based are comparable. Now then we have another thing for calculation of the death rate, that is the age specific death rate. We can see that age specific death rates we categorize the population into different ages from 0 to 4, 6, 5 to 9, 10 to 14 and other more rows. So it is also not right because it is cumbersome to use a series of age specific death rates. So what is the basic of standardization? How can we compare mortality rate between two different populations is by direct standardization and indirect standardization. Now, what is a standard population? A standard population is that in which the age and sex composition is known precisely as a result of census or by an arbitrary means. For example, the Pakistan population is known to be 22 million, and we also know its different age, different number of population in various age categories and its sex composition. So Pakistan's population is said to be standard population. The standardization of death rates. Therefore, we use the age adjustment or age standardization, which removes the confounding effect of different age structures and yields a single standardized or adjusted rate, by which the mortality experience can be compared directly. The adjustment can be made not only for the age but also for sex, race, parity, and others. Thus, one can generate age-sex and race adjusted rates. Standardization has compared the mortality rates between the groups with different age profiles. The examples are men with female, indigenous cultures with general population, country to country, and standardization is otherwise there is biasing of mortality rates between the groups. Now we will discuss about the direct standardization. In direct standardization, actual death rates in the subpopulation is known. Then we find the expected deaths in the standard population, and then we apply the A standard mortality rate. Here is an example of the Karachi and Lahore to find out the age-adjusted mortality rate. In For this, the first step is to get a specific death rate for population of interest. For example, as we are taking the population of Karachi, so the formula for calculating the age specific death rate is number of deaths of a person aged of that particular age during a calendar year by mid-year population of persons of that age group multiplied by 1000. As we can see that we categorize the data, or we divide the data into different age groups from 0 to 24, 25 to 54, 55 to 74, and 75 and above. The mid-year population is 9.9, 13.8 and other, and deaths are these. So we will get the age specific death rates per thousand population uh, if we take this number deaths in year like 1034 in numerator and divide it by 9.9 million and take it in the denominator and multiply it by 8000, then we will get the age specific death rates per thousand population. We will calculate the age specific death rate for all the age categories Then there is another example of Lahore. The first step is again the same. We will get the age specific death rate per thousand population in the same manner as we calculated previously. Then the next step is, or the second step is, use these rates to find the expected deaths. The second step is to find the expected deaths in the standard population of Pakistan, that our population under study is Karachi. So how we find the expected deaths? The formula is to standard population multiplied by age specific death rates by 1000 population. So first, for expected deaths, we have the standard population. We will multiply 61 million by 0.1 and then divide by 1000. Then we get the then we get the expected deaths of 61,100 for the age group of 0 to 24 for the Karachi. Similarly, we are finding the expected deaths of the Lahore in the same manner. Then the third step is find age standardization death rates. Now, how we find the age standardized death rate for Karachi? Uh, we will put the formula total expected deaths over total standard population multiplied by 1000. As the total expected deaths we calculated in our previous slide is 1598700, and the total standard population is 81.6 million, and we multiplied by 8000, and then the age standardized death rate calculated to be 1.9, while that for Lahore is uh, 2.1. So we can say that the CDR, which we also calculated in the previous slides of Karachi, is 1.8, while we assume that the CDR per thousand of the Pakistan standard population is 2.5. Or then how we interpret this data? The standardization for age distribution has increased the CDR of Karachi from 1.8 to 1.9. When considering the same age distribution as rest of Pakistan, the death rates of Karachi seems to be better than rest of the Pakistan population. And we would interpret the data of the Lahore. The standard for age distribution has increased the CDR of Lahore from 1.7 to 2.1. When considering the same age distribution as rest of the Pakistan, the death rates of Lahore seems to be better than rest of the Pakistan's population. Now, fourth step is find out the comparative mortality ratio. This is the last step after uh, uh, death standardization. So the comparative mortality ratio is can be calculated by dividing the age standardized death rates of one population by the other population. So in our example, the age standardized death rate of Lahore is 2.1 and that of Karachi is 1.9. So the comparative mortality ratio is 1.10. To convert the comparative mortality ratio into percentage, multiply it with 100. We are multiplying this value 1.10 by 100, so we get the percentage. So the percentage is 110%. So how we interpret this? We can interpret this mortality rate in Lahore is 10% more as compared to Karachi. So we can say that the mortality rate in Lahore is 10% more as compared to Karachi, or the health indicators or the health status of the Lahore is uh, poor than that of Karachi. Now the other form of the standardization is the index standardization. This is the simplest and most useful form of the index standardization. Uh, in it, we need to know we have the data of the mortality rates of the standard population. Then we find the expected deaths in the study population, and at the end we find the standardized mortality ratio. Now, what is standard mortality ratio? Standard mortality ratio is the ratio usually expressed in percentages of the total number of deaths that occur in the study group to the number of deaths that would have been expected to occur if that study group had experienced the death rates of the standard population. In other words, standard mortality ratio compares the mortality in the study group, for example, an occupational group, with the mortality that the occupational group would have had if they had experienced national mortality rates. In this method, the most stable rates of the larger population are applied to the smaller study group. It gives a measure of likely excess risk of the mortality rate due to occupation. Now, how we calculate the standard mortality rate? The formula is observed deaths by expected deaths multiplied by 100. We will discuss here the two examples to find out the standardized mortality ratio. First example is of the coal miners, and the question that needs to be answered in first example is if an occupation carries more risk or not. And the second example is of the do black Americans have a higher COVID-19 mortality rate than the general American population. So first example is of the coal miners. The first step to find out the standardized mortality ratio is to calculate standardized mortality ratio. A specific death rate of the standard population is necessary. So we take the reference population or the a specific death rate of the standard population. It is available already. So the second step is identify the coal workers population in various age groups. We can find that from 25 to 34 age group, there are 300 coal workers. Then third step is the total number of observed deaths in a specified year, for example, in 2019. We calculate, then we have the data of the observed deaths of the whole of the population. Uh, in while calculating the SMR, we don't have the observed deaths for the individual age groups. Like in this example, we don't have the data of the how many numbers of the persons who died in the age range of 25 to 34, 35 to 44, and others. We have only the data of whole of the community. For example, we have the data that there are 9 coal miners whose occupation is coal working, who are died in their occupation. Then the fourth step is to calculate the expected deaths. Now how we calculate the expected death? The formula is population under study multiplied by a specific death rates of standard population divided by 1000. So we calculate it by multiplying the population under study, that is 300, and by multiplying it with the age specific death rate, that is 3, and then divided it by 1000. Then we calculate all the expected deaths of all the age ranges, and then at the end we will submit, and this comes out to be 7. There are 7 expected deaths that have to be occurred between in the coal workers. So at the end, as a standardized mortality ratio is calculated by dividing observed deaths by expected deaths. So the observed deaths are 9 and the expected deaths we calculated is 7. So we divide both of them and then multiply by 100. Then the answer is 1 to 9. So the standardized mortality ratio is 129. So how we interpret this standardized mortality ratio? The rule is if standardized mortality ratio is more than 100, then the occupation would appear to carry a greater mortality risk than that of the whole population. And if the standardized mortality ratio is less than 100, then there is less mortality risk, or the occupation they are having is protected for them and there is little risk of dying due to occupation they have opted. So in the previous example, our standardized mortality ratio is 129. Is 129%, which means that their mortality rate was 29% more than that of experienced by the national population. Now, what are the advantages of standardized mortality ratio? The SMR has the advantage of the direct method of age adjustment is that it permits adjustment for age and other factors where age specific rates are not available or are unstable because of small numbers. And one needs to know only the number of persons in each age group in the study population and the age specific rates of national population. It is possible to use SMR if the event of interest is occurrence of disease rather than death. In England, it is the basis for the allocation of government money to the health regions of the country. The concept is that the regions with higher mortality also have the higher morbidity and should therefore receive proportionally higher funding to combat ill health. Now we have another example for the index standardization, that is of the Black Americans. Do they have a higher COVID-19 mortality rate than the general population? The study under population is the Black Americans, and the general population of the standardized population is the general population of the America. So the first step is find mortality rates in standardized population groups. Then the second step is used study population age distribution to find the expected deaths. We find the expected deaths by multiplying the population under study by age specific death rates by 1000. Then we calculate the standardized mortality ratio. In this example, the standardized mortality ratio is 142%. So how we interpret this? That do black Americans have a higher COVID-19 mortality rates? Interpretation is that black Americans have the higher mortality rate, that is 42% high than that of the general population. So the time for the recent updates. First article is about the title is Ethnic Differences in COVID-19 Mortality During the First Two Waves of the Coronavirus Pandemic, a nationwide cohort study of 29 million adults in England. The main points in the study is that cohort study between ethnic groups in the first wave from 24th January 2020 until 31st August 2020, and the first part of the second wave from 1st September to 28th December 2020. In the first wave, all ethnic minority groups have had a higher risk of COVID-19 related death compared to the white British population. In the second wave, the risk of COVID-19 death remained elevated for people from Pakistani. Uh, their standardized mortality ratio is 39.9% and 166.8 deaths per thousand per 100,000 population in men and women. While for Bangladeshi population, it is 318.7 and 127.1 in men and women background, but not for the people from black ethnic groups. The second article is risk of mortality due to COVID-19 and air pollution in Pakistan. The observed mortality due to COVID-19 has been standardized over the entire population using the standard age group ranging from 0 to 4, 5 to 9, 10 to 14, and so on. The impact of air pollution and COVID-19 and transits among Pakistan areas that are the Islamabad Capital Territory and FATA was analyzed. The result indicates that the observed mortality rate is much higher than the predicted in certain provinces, namely the KPK and Punjab, and the prevalence of particulate matter 10 was independently linked to the mortality due to the coronavirus. Now the time for the MCQs. First MCQ is, a researcher is comparing the mortality rates of Pakistan and Afghanistan. He prefers to use death standardization to eliminate the difference of whether the causes of death, numerators, age distributions, denominators are deaths in epidemic.
C.
Yes, C, age distribution is the correct answer. Second MCQ is, the crude death rate in community A was higher than crude death rate in community B, but the age adjusted mortality rate was higher in community B than in community A. This indicates that whether investigators made a wrong calculation or the no inferences can be made about the comparative age of the population from this data, or the population of community A is on average older than that of community B, or the population of community B is on average older than that of community A, or the health status of community B is on average better than community A.
B.
Yes, C. C is the correct option. The population of community A is on average older than than that of the community B. Third MCQ is, a medical student is assigned a task to find out the mortality data of two cities by means of death standardization. During his assignment, he might need not a specific death rate is needed, or a standard population is needed. Our population should be comparable. Our two populations are compared. Our morbidity of both populations, which he might not need. All these things are needed. For example, he also need to calculate the specific death rate. A standard population is also needed, and population should be comparable, and two populations will be compared at the end. So with the thing that we don't need is the morbidity data of the both populations, because we are working only on the mortality data. Fourth MCQ is, standardized mortality ratio permits adjustment where A specific rates are not available or are unstable because of small numbers like in intravenous drug abusers, which may not be helpful or true for assessing standardized mortality ratio. Whether uses crude death rate as a yardstick or is calculated by observed deaths and expected deaths or permits adjustment for age of under study population or can be used for disease as event of occurrence or can be used as a tool to higher payments of risky populations.
A.
Yes, A is the correct answer because in standardized mortality ratio we don't use a crude death rate. Fifth MCQ is when studying the death rates patterns of a population, why do demographers usually analyze age-specific death rates instead of the crude death rate in their research? Whether because death rates vary considerably by age or because we can't accurately measure death rates per year because the Center for Disease Control and Prevention won't release annual death rates in timely manner or so that we standardize death rates and exclude deaths related to acts of violence or because the world population is growing very fast.
B. B.
No, because deaths vary considerably by age. As we have seen in many paragraphs that death rates vary from 0 to 5, 5 to 10, 6 to 10. In older age, death rate is much higher than the young age. So age-specific death rate we consider because deaths vary considerably by age. Sixth MCQ is, since 2017, country X has experienced a large outbreak of monkeypox with over 500 suspected cases and over 200 confirmed cases. The observed death rate due to monkeypox is 45 and expected death rate in that country is 30. Calculate the standardized mortality ratio. These are the easy calculation. So the formula for calculating the standardized mortality ratio is observed deaths by expected deaths multiplied by 1000. So in this case, we have 45 observed deaths and 30 expected deaths, and when we multiply it by 100, it comes out to be 150 50%. So the correct option is E, 150%. Seventh MCQ is also related to the previous MCQ. Since 2017, country X has experienced a large outbreak of monkeypox with over 500 suspected cases and over 200 confirmed cases. The observed death rates due to monkeypox is 45 and expected death rate calculated in that country is 30. Its standardized mortality ratio is calculated to be 150%. How will you interpret it? Whether mortality rate due to monkeypox is 50% higher than that of country or mortality rate due to monkeypox is 50% lesser than that of country or the mortality due to monkeypox is 100% higher than that of country, or mortality due to monkeypox is 150 times higher than that of country, or the mortality due to monkeypox is 150% lesser than that of country. How will you interpret it? This 150%.
D.
Uh, A, alpha is the correct option because
Okay.
while interpreting we will only use those values that is above the 100. So above 100 is only 50%. So the mortality due to monkeypox is 50 times higher than that of the country. A is the correct option in this scenario. Eighth MCQ is to calculate the mortality rates by that standardization. Standard population is taken. Standard population is that which has whether excellent health indicators or belongs to a developed country, has had age and sex composition known, or that the death rate is higher than the birth rate or adopts healthier lifestyle. Which is the character of the
D.
standard population?
C.
Yes,
C.
C is the correct option. The standard population is that one who, in which we knows its age and sex composition. Ninth MCQ is the rate adjusted to allow for the age distribution of population to compare the death rate of two countries is whether perinatal mortality rate, crude mortality rate, fertility rate, age standardized mortality rate, or disease specific death rate.
D.
Yes, D, age standardized mortality rate is the correct option. 10th MCQ is the crude rate of Pakistan is 9.1 per thousand population. Flood affected population of Pakistan have observed death rate of 30,000, while the calculated expected death rate is 25,000. What interpretation can be made by this data regarding the death rate of flood affected population? The observed death rate is 30,000, while the expected death rate is 25,000. Whether the flood affected area has experienced higher casualties, whether huge casualties will be experienced in near future, or whether not much casualties occurred as expected, or whether the large casualties has been prevented due to rescue operation, or the famine is the major contributor of the casualties. Which interpretation can be concluded by this?
A,
A.
Yes, A is the
A,
correct option. Flood affected area has experienced higher casualties. So who will interpret this data? That the interpretation needs to be standardized mortality ratio. To calculate the standardized mortality ratio, we put the observed death rate, that is 30,000, in numerator, and put the expected death rate in numerator, that is 25,000, and this comes out to be about 120%. So the answer is, so we interpreted that the 20% higher causality is in flood affected area. So A is the correct option. This is the queue of my MCQs, and thank you very much.
Very well done, Dr. West. Thank you very much. I hope everyone has learned a lot. This is a very important but difficult topic. And I have seen, being an examiner and a supervisor for a long time, that most of the people who have difficulty in the understanding of standardization and calculation of important rates like SMRs, MMRs, and other important things, they have not been able to get through their assessments and examination process, and so the accreditation process in order to get them certified, that all suffers. I am very hopeful that all the students who have attended today's class, they have understood the concepts, how these calculations work, and I have to appreciate the hard work of Dr. Awais, who has cleared each and every concept in such a detail, and also the timekeeping and time management, that was excellent. Very well done, Dr. Awais. See
Thank you,
you
ma'am.
all, okay, inshallah, in the next class. Allah Hafiz.
Okay, ma'am. Allah Hafiz.